Which of the following would result in the widest confidence interval? A sample size of 100 with 99% confidence, a sample size of 100 with 95% confidence, a sample size of 30 with 99% confidence, and a sample size of 30 with 95% confidence. So it looks like we have some choices between sample size and levels of confidence. Each of those are going to have an effect on how wide the confidence interval is in the end. Let's try and think through how that might work together. So let's talk about the confidence level itself. We begin an interval estimate with what's called a point estimate. So your point estimate is just a single value based off of a sample that gives you one data point, okay? And that point estimate, it could be right or it could be wrong, but it's very likely that it's not correct. Because the thing is, if you're trying to predict the outcome of an election, if you poll voters and you say, all right, I polled 50 people and 35 are voting for this one particular candidate. So your prediction of the outcome of the election is 35 over 50, and that is a probability of 0.7. So you're saying there's a 70% chance that this person will win the election. But who knows? Maybe that's an accurate prediction, but it's not really exactly. So the prediction ends up actually being the actual percentage of people who vote for this candidate is 66% or something, which is close, but it's not exactly the same. So the confidence that you can have in a single point is very low. When you include an interval, now you're saying, okay, from this point over to this point, perhaps between 67% and 73% instead. So then there's a much more likelihood that the actual percentage of the vote will be somewhere between those two values. And maybe this is your 90% confidence level. Well, the more confident you are of the result, the wider that confidence level is going to be. So when you increase confidence, you get a larger confidence interval. All right, so that means let's strike out anything with 95% confidence, because if you have 99% confidence, then that's going to certainly give you a wider interval. All right. Well, let's see what happens with sample size. So again, let's say we are polling people for an election. If I poll 30 people for an election and someone else polls 100 people, whose result do you trust more? Well, the person with the largest sample is going to have the more accurate result. And so you can be more assured that you have a better estimate with a larger sample size. So if you have a smaller sample size, then that's going to increase the width of your confidence interval because you have lower confidence in your result, but a larger sample would give you more confidence in the result, which means you have a smaller interval. So the thing that would result with the widest confidence interval is this right here, the smallest sample size and the largest level of confidence. And if you aren't sure about that result, then you have enough technology just to play around with and see what the results may be for different levels of confidence and sample sizes. For instance, you could go under your stat and tests and come down to 1 prop z interval. There we are. And you could, you'd have to make up a value for x, but let's say you put 67 out of a sample size of 100 with a level of confidence of 99%. And then you could see what the size of that interval is. All right, then if you try the experiment again, but this time, oh, I passed it. But this time, you can change your sample size down to 30, but leave the level of confidence the same. And then, well, oh, it gave me a domain error because x is larger than n. So I'd have to do something like 67% of 30. And then it won't accept a non-integer value, so I'll just switch that down to 20. It shouldn't have too much of an effect. And then you can see what the interval looks like then. And at that point, you could try just different values according to these rules here and see what results in the widest interval. And that can show you how to do this problem as well.